Hello, welcome everyone. We're so glad to have you join us today. The Iowa Breastfeeding Coalition is pleased to offer this special presentation for National Breastfeeding Month entitled Third-Hand Smoke During Pregnancy, Lactation, and the First 1,000 Days. We will be providing continuing education for the presentation today. Continuing education for nurses and CERPs have been approved, and dietitian continuing education has been applied for. Continuing education is offered only to those that attend the session live today, and you must attend the entire presentation to receive continuing education. We are going to share a link for a Google form in the chat a little bit later, so please make sure that you complete the Google form if you'd like to receive a certificate of attendance with continuing education. We will be recording the presentation today, and it'll be posted on our IBC website for those that are unable to attend live, but continuing education will not be provided to those that watch the recorded presentation. So welcome everyone, and I'll let Madeline introduce our wonderful speakers.
Good afternoon. We will start our speakers off with Dr. Lydia Greiner. She is a psychiatric mental health nurse practitioner and an adjunct professor of psychology in the College of Sciences at San Diego State University. Dr. Greiner's primary research interests are in the prevention of environmental exposure to tobacco residue in indoor and outdoor environments. She's an associate director of the Thirdhand Smoke Resource Center, the co-director of the Policy Research Center on Tobacco and the Environment, and an investigator on several funded projects investigating the toxic legacy of tobacco in indoor and outdoor environments. Dr. Greiner enjoys exploring national parks and spending time with her family. And then we will have Dr. Thomas Northrup, an associate professor in the Department of Family and Community Medicine at the University of Texas Health Science Center at Houston McGovern Medical School. Dr. Northrup's primary research interest is in the prevention of environmental tobacco smoke exposure for infants admitted to the neonatal intensive care unit, especially infants who may be discharged to homes where individuals who smoke or vape reside. In 2018-2019, he completed data collection and analyses for a National Institutes of Health funded RO3 exploring several aims relevant to third-hand smoke in the NICU. Dr. Northrup is an avid runner and enjoys spending time with his family and cheering for his son's soccer and baseball teams. And then we will finish our afternoon with Dr. Mojave Gittens, a professor of pediatrics at Cincinnati Children's Hospital, Medical Center, and the College of Medicine at the University of Cincinnati. Dr. Mojave Gittens' research focuses on examining child exposure to tobacco smoke toxicants in the clinical and home setting, and on implementing strategies to educate parents about the effects of tobacco smoke on their children and to help parents quit smoking as a way to protect their children from exposure to tobacco smoke toxicants. Dr. Mojave Gittens is the PI and co-PI of 2 RO1 trials designed to reduce child exposure to tobacco smoke, to measure and examine the contribution of third-hand smoke in children's environments to their overall tobacco smoke exposure, to measure the levels and composition of third-hand smoke in the homes of smokers who have quit, and to examine the clinical effects of third-hand smoke on children's health. When Dr. Mojave Gittens is not busy with her research and taking care of patients, you can find her in the theater enjoying a musical or classical music concert, taking pictures of her family, or speed walking. Thank you for speaking today, and take it away, Dr. Greiner.
Thanks very much, Madeline. We are very happy to be here to celebrate National Breastfeeding Month with you all, and we look forward to spending the next 90 minutes with you. So we are part of the Collaborative Consortium on Third-Hand Smoke. What is this, you may be wondering? The consortium is a multi-institutional, interdisciplinary, programmatic, and translational research effort, which actually what that is we are all members or affiliates of the consortium. We have more than 40 researchers from the US and across the globe, and we share a common interest in and research on third-hand smoke. It includes folks who are bench scientists to people who are experts in communication. This research group started in 2011 with a focus on commercial tobacco, but over the past more than a decade has expanded the focus to include e-cigs and cannabis. And I am very confident that as the tobacco industry becomes ever more creative in delivering their products, we will expand to match that. We are funded by the California Tobacco-Related Disease Research Program. Our agenda today is I will be providing an introduction to third-hand smoke. Tom will be talking about breastfeeding implications and third-hand smoke in hospitals and NICUs. Melinda will continue with a discussion of third-hand smoke at home, and then we're going to wrap it up with what we hope will be a discussion with you about what to do about this, including policy implications. The learning objectives, I'm just putting them up there because we know this is, you will get continuing education units for this. You might as well know what our objectives are for today. So what exactly am I going to be talking about? Third-hand smoke. I have no conflicts of interest to declare. We are funded, as I mentioned before, by the California Tobacco-Related Disease Research Program. We have a specific grant to disseminate information about third-hand smoke to the public and stakeholder groups. I want to give a shout out to our leadership team. Jorg Matt, a professor of psychology, is the director of the Third-Hand Smoke Resource Center. Rachel Record, who's an associate professor of communication, and I are associate directors. And Sarah LaValle is our incredibly valuable center coordinator, without whom none of this work would be possible. Before I jump into my presentation, I wanted to mention two things. One is I'll be using some of the infographics that we've created to translate the science of third-hand smoke for the general public. And I'm using these because we hope that you can begin to think about how you will share what you're learning with families you work with. All of the infographics that I'll be using, plus many others, are freely available on our website. And the other thing I want to mention is that when we use the word tobacco in this presentation, we are speaking specifically about commercial tobacco. We, as I'm sure you do too, we have many tribal nations in California, and we recognize the use of sacred tobacco as distinct from commercial. So I will not say commercial every time, but you can know that that's what I'm referencing. So what exactly is third-hand smoke? I like to start with the definition so we're all on the same page. I know we're all familiar with first-hand smoke, which is what the person who's smoking breathes in, and second-hand smoke, which is what is in the air around someone who is smoking. Third-hand smoke, the simplest definition, is the toxic chemical residue that remains in indoor environments, on surfaces, in dust, and in the air after smoking stops. So while the term third-hand smoke might be unfamiliar to many, most of us have experienced it. If you've ever walked into a space like an elevator where no one is smoking, but you can smell stale tobacco smoke, you've been in the presence of third-hand smoke. If you sat next to someone on a bus or train whose clothes smelled like stale tobacco, the same. You went to a party where people were smoking, and when you got home, your hair smelled, same. And these are just a couple of illustrations of how we have observed third-hand smoke residue, chemical residue on objects and on people and on clothes in homes and communities where we are working. I think the saddest picture of all of these is Katie, whose clothes stink because she lives with someone who smokes. And we have reports of kids in public schools here who have been disciplined for smoking when it turns out they don't smoke at all, but they live in homes where their parents do. What we now call third-hand smoke starts out as secondhand smoke. Secondhand smoke is 15% what is exhaled by the person who's smoking, and 85% is from the smoldering tip of the cigarettes. and that's called side stream smoke. That's a really important distinction because the smoldering smoke is burns at a lower temperature, and it is therefore significantly more toxic because it's incompletely combusted and so has a higher proportion of more toxic compounds. When we see secondhand smoke, it looks like a gray cloud. And the cloud we see is actually a collection of tiny droplets of literally thousands of different chemicals and even smaller, ultrafine, invisible droplets and volatile, fast-moving gases. What we smell are the volatile gases. It looks like it disappears, but it simply becomes invisible to us. As you may know, secondhand smoke, gases, and particles quickly travel considerable distances throughout rooms within a home or building. It travels down hallways in apartment and condo buildings. It travels into neighboring units. It travels through utility ducts, ventilation systems, and around plumbing spaces. It remains in the air actually for up to 3 hours after smoking has taken place, depending on the ventilation and the air exchange. But importantly, the transformation into third-hand smoke begins within seconds of lighting a cigarette. The gases stick on surfaces and are soaked up, and the particles are deposited in dust. I like this slide because it really makes it an easy way for us to remember how third-hand smoke behaves. It's the 4 R's. So over time, as smoking occurs indoors, the chemicals remain on surfaces in the dust and actually become embedded in objects: carpets, blankets, furniture, sheetrock, ceiling tiles, insulation. And these items actually become reservoirs of third-hand smoke chemicals, which can be then re-emitted back in the gas phase from these reservoirs. Sometimes we can smell that. It smells like stale tobacco smoke, but not all of the compounds actually have an odor. These particles can be resuspended in the air from the dust deposits in which they're living. And also, the chemicals can react with oxidants and other compounds in the environment when they are released back into the air, and they actually create new toxic compounds and fine particles that were not present in the secondhand smoke. One of these is tobacco-specific nitrosamine called NNA, which is a known carcinogen. So it is not smoke, strictly speaking. It is, in fact, a mix of toxic chemicals. So in California, we have Prop 65, which requires owners or producers of products to post that particular chemicals that are known to be carcinogens or reproductive or developmental toxicants are either in the product or in the space. So in virtually every building that you enter in California, you will see a Prop 65 sign. And many products that are manufactured here come with a Prop 65 warning label if they're shipped out of state. Interestingly, tobacco smoke is actually listed on Prop 65, and the sources of it are described as first, second, and third-hand smoke. But third-hand smoke itself is not listed on Prop 65. So what I'm showing you here are the 27 compounds that are in third-hand smoke that are on our Prop 65 list. So that means they're all carcinogens or developmental reproductive toxicants. I've highlighted a few of these because they're chemicals that you would most likely know or recognize. And also I'm going to reference some of these in a study that I'm going to show you a little bit more about in a minute. So what do these chemicals do? First, just because I just mentioned there are 27 chemicals on Prop 65 doesn't mean that the other chemicals in third-hand smoke are safe. Based on the available research, we know that chemicals in third-hand smoke have a range of health impacts, some of which are illustrated on this infographic, and I know that Melinda and Tom are going to talk about this more later. But I do want to mention that third-hand smoke exposure can be short-term or chronic long-term. And short-term exposure refers to, for example, you check into a hotel and the only room they have available is a smoking room. And so you're stuck and you stay in it for one night, or you visit the home of a friend who smokes. Short-term is minutes or hours. And people report a range of symptoms when they experience this, from various respiratory symptoms, allergic skin reactions, headaches, earaches, eye and throat irritation. Chronic long-term exposure, I'm talking about living in a home that is polluted with third-hand smoke or daily close contact with someone who smokes. So we're talking about days or months or years of exposure. And that kind of exposure has been demonstrated to produce DNA damage in human cells or in animal models, changes in the immune system and immune response. It interferes with organ development in children. It causes changes in the reproductive system, liver function, wound healing. The list goes on. Where is third-hand smoke? It's been found in a wide variety of indoor environments. One would expect to find third-hand smoke in homes of active smokers, but unfortunately, that's not the only place that we found it. So we found it in homes of people who do not smoke, who move into homes or apartments where previous residents smoke, who live in multi-unit housing where other residents currently smoke in neighboring units or shared spaces, who live in multi-unit housing where others may have been allowed to smoke years ago, in hotels and entertainment venues where smoking is allowed on the property, either in designated areas or rooms, or where it was allowed on the property in the past, in pre-owned personal items, including furniture and vehicles that were previously owned or used by someone who smoked, and in work sites, including healthcare facilities where workers smoke in shared spaces. This is particularly a problem in industry where vehicles are shared and people smoke in the cab of the truck, and the next person who is a non-smoker comes along and then is exposed to third-hand smoke in that environment. A couple of research studies to convince you of the pervasiveness of third-hand smoke. There's a lot that's going to be going on this slide, so I'm going to take a minute to go over it with you. On the horizontal axis here, you see 220 apartment units in San Diego where we measured chemicals that are nicotine, actually, and other tobacco-specific nitrosamines in air, dust, and on surfaces. So 220 units. These are all people. The blue units, let me show you. Sorry, I'm sorry. I want to go back one moment. So the y-axis, or excuse me, the x-axis, horizontal axis is the units. The y-axis, or the vertical axis, shows the surface nicotine concentration in micrograms per meter squared. And it goes from 0.01 all the way up to 4,000. That's kind of like looking at a Lego block and then looking at the Rocky Mountains. That gives you some idea of the scale between those two measures. So in the blue, we have the units of people who do not smoke and have strict smoking bans in their apartments. The light blue say that they're not exposed to secondhand smoke. The darker blues say that they are exposed to secondhand smoke outside of their homes. The orange bars represent people who don't allow smoking in their home and they smoke only outside. The red are people who smoke and they smoke inside their home. So you would expect to see higher levels in the red homes than in the blue ones. The black line here, let me try to highlight that. My cursor, the black line at less than 1.6 is really what we see typically in homes where there people don't smoke and where there is a smoking ban. They don't allow smoking in their homes. This line over 30 is what we typically see in homes where people smoke indoors. So 10% of the units where non-smokers lived in this study had levels above the 30. So their levels looked like homes where people smoked inside. About 5% had levels that were like we find in rooms where people smoke in hotels, and 2% had levels that were what we see in casinos. And remember, these are all homes where people do not smoke and do not allow smoking in their homes. A couple of really interesting examples that shows the persistence of this. This person was a non-smoker with a smoking ban who had lived in their apartment for 10 years, and they were well above the 30 micrograms per meter squared. This person was another person who did not smoke, did not allow smoking, and had been in their apartment for 2 years. This person had been in his apartment for 10 years. His level is really sky high, well above what we see in homes of active smokers. His wife had smoked 15 cigarettes a day, and she had died 3.5 years previously. And lastly, this person had lived in his apartment for 21 years. He had not smoked for the past 9. He had previously smoked a pack a day. So I think these individual cases really represent the persistence of this residue in indoor environments after smoking has stopped. Another example from a home in Oakland, California. This is a more recent case study. We offer do-it-yourself testing to people in California who are concerned about third-hand smoke in their homes. This is a family who had purchased a new home. They have 2 preschool-age children, and dad works from home. They noticed the smell of tobacco once they had purchased the property and requested testing. And these are their results. They collected surface samples, just took a simple wipe from a living room shelving, from an upstairs bedroom wooden shelving, wood trim in the doorway of their home, and then an air duct in their living room. In the image on the bottom, in the figure 1, the blue line represents what we typically see in homes where people do not smoke and there is a strict smoking ban. So there's always a little bit of background nicotine present in virtually every home that we test. The pink bar represents people who smoke, but only smoke outdoors. The red represents people who smoke indoors. You can see there's some overlap in those ranges. And you can also see that in this home, every single sample was well above what we see in homes of active smokers. So now they are facing the question of what do we do about this before we move our family into our home. I'm going to switch to public venues and share the results of a study of movie theaters. This took place in Europe. And this is the graph on the right is the hazardous air pollutants that were found in this non-smoking movie theater measured in the evening. And it shows the equivalent of secondhand smoke in cigarettes per hour. So naphthalene, for example, per hour, the exposure was equivalent to the secondhand smoke from 10 cigarettes. Benzene, similarly. And you'll remember that naphthalene and benzene were both on that list of chemicals that I showed you, that big chart of chemicals that are known to be carcinogenic and or developmental toxicants. And lastly, a quick side note about cars. This is a study of rental cars, but this similar findings apply to, or similar information applies to used cars that are purchased. This was a stratified random sample of 250 cars. Some of them were identified as non-smoking rental cars and others were identified as smoking rental cars. And the third group was unknown. And dust, surface, and air samples were collected. Third-hand smoke chemicals, nicotine, was detected in each type of sample, dust, air, and surface, in both smoking and non-smoking vehicles. It was higher in older cars and cars with more mileage. It was higher in vehicles that were labeled as smoking compared to vehicles that were labeled as non-smoking. In California, you're not required to report if you are selling a used vehicle, whether or not the prior owner smoked. But we do know that in cars that are older and cars with more mileage, the nicotine levels were higher in this rental car study. So how are we exposed? It's in the air, dust, and on surfaces, and therefore there are several ways these chemicals can get into our bodies. We can swallow it if we put polluted items, including fingers, into our mouths. We can breathe it in when the particles and chemicals are in the air, and we can absorb it through our skin when it comes in contact with surfaces that have been polluted with third-hand smoke. Kids are a lot more vulnerable to this than adults for a couple of reasons. They spend a lot more time inside. They engage in hand-to-mouth behavior frequently. They spend time on the floor where dust collects. They breathe more rapidly than adults, so they have more chances to bring it in or breathe it in, and their immune systems are developing, so they are more vulnerable to the effects. Can we get rid of it? These are the user-friendly results of a study of homes that were polluted with third-hand smoke in San Diego. And this is a comparison of the amount of third-hand smoke in dust and on surfaces before and after a deep clean that was done by a professional cleaning company. So you can see that the amount of dust in homes before cleaning was in the yellow zone, which we are calling low, and it was reduced after cleaning. The amount of third-hand smoke on surfaces was moderate before cleaning, and it was reduced after cleaning. And it remained reduced for several months. However, after 3 months, the levels have returned to their baseline. We use the results of this to make recommendations to reduce exposure, which include opening windows daily to air out rooms, vacuum as often as possible to remove dust, using a HEPA filter if possible, and clean surfaces weekly using products with diluted vinegar or diluted bleach or white vinegar. Those are some references. I am going to stop sharing and turn it over to Tom. Melinda and I will be here through the entire 90 minutes, so we are not going to pause for questions here. We will take them at the end. Tom, you're on.
Great. Thank you, Lydia, and great job. So I just wanted to add on to Dr. Greiner's comment about questions. If you have questions as we move along, please put them in the comments, and the three of us are monitoring that so we can respond at the end. So very happy to have a chance to speak to this group. Huge advocate of breastfeeding and human milk feeding, and have some other work which I'm not going to discuss in this presentation today that I do through my role as a principal, one of the multi-principal investigators through the Environmental Influences on Child Health Outcomes cohort study, which is running right now. But today I'll talk a little bit about some breastfeeding implications and third-hand smoke in hospitals, and in particular the neonatal ICU or NICU. I don't have any conflicts. And Lydia, before I go any further, just want to confirm you can see my slides and they're advancing. Great. So I don't have any conflicts, just want to briefly acknowledge some funding for the data I'll present today. So some background on my research in this area. So the NICU is a highly novel place to do research. Sometimes people ask me why I'm interested in this, and I say, well, there's no secondhand smoke exposure up here. If we can't protect a place like the NICU from environmental tobacco smoke contamination, what kind of environment can we fully protect from contamination and exposure that occurs? And so over time, my work and the work of some others has demonstrated that contamination and infant exposure likely occurs in the NICU. We know from lots of previous work that at least a quarter of infants are going to discharge to a home with at least one individual who smokes or vapes. And really, it's probably closer to 33% these days in our own NICU. It's difficult to remove and lingers for over a year. And as Lydia was demonstrating, it can linger much longer in some of those apartments where it occurred for years. Despite hand washing policies in ICUs, there's some work to suggest that we're still clearly not doing as well as we'd like, and maybe only 40% of people are washing their hands as often as we would recommend with guidelines and policies in these settings. We can isolate the routes of transport, deposit, and exposure in the NICU. You know, we know people are bringing it in on their clothes, on their skin, and other items they bring to this area because, as I mentioned, there's no smoking, there's no secondhand smoke exposure here. But bottles and feeding tubes and other devices that are involved in human milk feeding get handled by staff and visitors, and they're exposed to, third-hand smoke as a result of that. And this ongoing ingestion can affect infants of all ages, not just those hospitalized or admitted to the neonatal ICU. And I'll mention this twice, but want to put this up front that we know that third-hand smoke, tobacco contaminants, has antifungal and antibacterial properties, which has implications for breast milk and downstream for the developing gut microbiome of infants. And so all of this collectively raises concerns for fragile or vulnerable children cared for in these settings. So some of the aims of my research to date have been to try to understand the extent to which visitors and medical staff transport third-hand smoke residues to the NICU. And then, of course, to quantify this, we do that in a couple of different ways by wiping surfaces on nearby furniture or incubators in these settings. We also get urine samples from infants to measure their exposure to nicotine. Specifically, we analyze a metabolite called cotinine, which is the primary metabolite of nicotine, and it's washed out through urine. We can also explore tobacco contaminants present in breast milk. So not just cotinine, which also is coming through breast milk or human milk, but we can also look for specific carcinogens which may be transmitted to an infant via human milk. And of late, I've begun to explore the impact on the gut microbiome for infants in the NICU based on their level of third-hand smoke exposure, and then trying to understand how we might clean or remediate, at the very least, third-hand smoke that's present on hands or fingers when caregivers are interacting with their infants. So very briefly, a high-level overview here. If you're curious about the methods we use to explore some of the work that Dr. Greiner presented and what I'm presenting here, we always do an interview or a survey with participants, primarily focused around household smoking and exposure. We do carbon monoxide breath samples to correlate that with someone's responses for whether they smoke or not. When we wipe when we wipe fingers and furniture, we use a cotton round that's doused with a solution of distilled water and ascorbic acid. And essentially what that does when we wipe is it converts nicotine to a salt and makes it easy to wipe away. And then we can understand how much nicotine is on a surface. When we do it on furniture, We use a standardized cardboard template depicted on the right-hand side of this slide at the top. And when we wipe a finger, we just wipe the whole finger, or as Dr. Mojave Gittins will talk about later, we might wipe the entire hand in some settings as well. For infant urine, I mentioned we analyze it for cotinine, the primary metabolite of nicotine. We collect stool, and then we can sequence it to understand all the taxa, bacteria, other things present in the stool sample. And then human milk is very similar to urine in some regards, and stool in others, in the sense that we can analyze how much cotinine is coming through, but we can also sequence it to try to understand the presence of certain health-promoting bacteria. And then finally, another method we often use are air nicotine dosimeters, which we hang about 2 meters above the ground for a week, and they measure airborne nicotine presence in whatever setting we're hanging them in. So hopefully that wasn't too in the weeds. Some of this first set of data I'm going to talk about on medical staff are published. This is an open access journal. If you would like to find this manuscript and read the whole thing, good bedtime reading. So what we did is we did a study with medical staff in our NICU here in the Texas Medical Center in Houston, and I approached 260 staff, had a very low refusal rate, only 5%. Primarily about 2/3 of the sample, that is, were nursing staff with good representation from respiratory therapists and physicians, nurse practitioners, and fellows or trainees in this environment. On that right-hand side in the red box, you'll see that there wasn't a lot of, current smoking. There were some individuals who reported living with someone who smoked currently, and some previous cigarette, or when you see the word ENDS in my slide, ENDS, that just stands for electronic nicotine devices or delivery system, electronic nicotine delivery system. There wasn't a lot of current use or exposure. And briefly, before I present the results of some of the finger nicotine wipe data from staff, I just want to comment that a nanogram is a billionth of a gram. So we're talking about a pretty small unit of measure, but when it comes to understanding tobacco contaminants, we really don't know what the safe level is. So even though this is a very tiny unit of measure, it doesn't necessarily mean that over time it's a tiny unit of harm, or that it's conveying less harm just because it's such a small metric that we're reporting. So the takeaway here is that a majority of medical staff, 80% in the NICU, still had measurable finger nicotine, which just means it was above the limit of quantification, the level that we can say that we detected some. And that might mean that they're coming in contact with it primarily in the NICU and kind of picking it up and then spreading it around to infants, or they might be bringing it in from public transit systems or exposure in their life. We need a little bit more research to understand exactly how staff might be contributing to the spread of this in a hospital setting. Next little bit of data are also published. There's two publications here. The top one is open access if you'd like to read the full report on data in this hospital setting from parents and visitors. And if you haven't been in a NICU in a while or ever, I just wanted to highlight that there are two types of spaces where infants might be cared for. There are shared pods where you might have up to 8 incubators with several nursing staff in them and lots of caregivers visiting the infants. They have an incubator and an incubator or bedside chair normally. And then when it comes to single rooms, these are exactly as you might expect. They have some surfaces, a counter that I've labeled there in blue, a crib, a chair, and then usually a fold-out couch. So the first bit of data I want to share is that when we hung those air nicotine dosimeters to try to understand the amount of airborne nicotine wafting around the NICU, we didn't detect any. Which is important to understand that the spread may not be due to gaseous emissions. We only hung 5 for this study. It was a little bit limited. Put one in a pod, we put one in a shared nursing space and some outer hallways. So this doesn't necessarily tell the full story, but it's an important piece of our current understanding of the spread in a highly protected medical setting. When we moved on to the next phase of this particular study, we tried to recruit all non-staff NICU visitors. So usually these were parents, but not always. It could have been a grandparent, an uncle, a friend of the family coming to visit an infant along with the parent up in the NICU. And we were able to recruit 210 participants. And of those, we wiped 63 individuals' fingers. And so that represented about a third of the sample. As you can see at the bottom in the red box, about 78% of the individuals coming into the NICU reported that they either smoked or lived with someone who smoked, and about 21%, I'm sorry, I got that backwards. So 78% were in completely tobacco-free homes, whereas 21% were in homes where at least one individual smokes or reports living with someone who does, including smokeless tobacco use. Because if you're chewing or you're pulling out dip, you're getting nicotine residue on your hands. So of course, if we wipe your finger, it's going to show up there. So what our data showed is that, regardless of what type of home someone lived in, about 2/3 or 62% had quantifiable finger nicotine on their way in the door. And it's important to note that all 24 of the individuals who we didn't pick any up on were from non-tobacco using homes. So, staff are bringing this in, visitors are bringing this in, but primarily the higher levels of transporting it in on hands is obviously going to be from individuals who live in tobacco using homes. Another facet to this study was to explore data specifically for mothers and their infants. We call this the dyad phase. So we recruited 80 mother-infant dyads at bedside. I over-recruited mothers or postpartum people from homes where at least one individual smoked, not always the mother or the postpartum person, but anyone living in the home. And we did an interview. We got a urine sample from the infant, which we analyzed for cotinine, and then we wiped some furniture at bedside in the infant's room. And these data will be reported in micrograms, which is a millionth of a gram. So we've gone from a billionth all the way up to a millionth now, so a slightly larger unit of measure. And what we showed here, the takeaway is in bold, is that about 94% of infants' rooms had furniture nicotine present. And that was regardless of home type. It didn't matter if the infant was going to discharge to a home where at least one individual smoked or to a home that was completely tobacco-free. We still found most of the furniture had nicotine on it. And you can see that there was slightly more on the furniture for infants being visited by individuals who smoke or live with someone who smokes. But the important takeaway in my mind is that it didn't really matter that the nicotine is still present up here, despite pretty vigorous cleaning protocols. Wiping the furniture periodically in these spaces occurs, especially at discharge. Cleaning staff are coming in and out of these rooms and wiping surfaces occasionally during hospitalization. So it's not like these rooms are going months and months without being wiped or cleaned. The infant urine data, as you might expect, infants on the right side of that set of red boxes had nearly double the amount of cotinine detected. But once again, regardless of what type of home an infant was going to discharge to, 94% of the infants had measurable levels of cotinine. And, this is important because some parents may be expecting that their child is going to be completely protected from nicotine in this setting. And if we were to collect a urine sample from an infant who's being visited by someone who doesn't smoke, you can imagine their surprise if they think they're extremely well protected from secondhand and thirdhand smoke, that we can pick up nicotine in your infant's urine sample. And this is well after in utero. Most of these data were collected about 2 to 3 weeks which is normally it takes about 5 days for in utero exposure to wash out completely, or the half-life of cotinine to have lapsed 5 times, and we would expect levels even lower than this at that point. So just wanted to underscore that this isn't necessarily, the pregnant person's exposure during pregnancy that's then showing up in the infant once we measure them in the NICU. Another publication in this area on the gut microbiome in the journal Environmental Research. So let's give a little bit more background on the microbiome. It's in the news a lot these days. There's lots of recommended foods. It's kind of a buzzy topic. You've probably heard of it, but it's the collection of microorganisms present in the gut, bacteria, fungi, and earlier I mentioned that we know third-hand smoke and nicotine residue have antifungal and antibacterial properties, and so research on adults has demonstrated that those who smoke have less gut microbiome diversity compared to those who simply vape or don't smoke at all. We know that gut microbiome dysbiosis, which is just an imbalance of these microorganisms or microflora during infancy or childhood, can be associated with some health outcomes we don't want to see, such as poor growth, particularly in malnourished children, or death and neurodevelopmental delay, particularly if infants are born, moderately or more preterm before 32 weeks. And if you've heard of any bacteria during infancy, and this group in particular being well educated on the benefits of human milk feeding, to say the least, you probably know a bit about Bifidobacterium, and particularly the species Infantis. And 100 years ago, when a majority of infants or all infants were being breastfed or fed human milk, the gut microbiome of infants was essentially a monoculture, meaning all you would see was Bifidobacterium present. Nowadays, even infants who are exclusively breastfed or receiving, human milk through a bottle primarily as the only source of their diet or nutrition, you're going to see a lot more variability in their gut these days because there's just a lot more environmental contaminants, not just tobacco, but things that are likely impacting the developing gut microbiome. And we want to see more Bifidobacterium because, just to present one finding, we know that if you have a greater abundance of this after 2 months, it's likely to lead to better vaccine responses, as demonstrated through some work here in this citation I've provided. So it's not just an academic exercise to understand, what's going on in the gut. It really has some downstream health impacts, which are contributed to directly by human milk and breast milk feeding. So continuing on with, characterizing these samples, it keeps getting smaller. So now we're down to 43 of these mother-infant dyads who also were able to give us an infant stool sample that we could sequence. And I got some human milk samples from these individuals. And of the individuals in the smoking household, about 81% were living with someone who smoked. And then 6 of these individuals were smokers themselves. And you can see down there in the yellow box that 40% of these people were living with someone or living in a household that could be considered like a heavy smoking household where more than or equal to 10 cigarettes a day were being smoked. Don't want to belabor that point, but the infants were all admitted to a NICU, so they were on average slightly below low birth weight. They tended to be born before 34 weeks gestational age, but there was some variability. And I apologize, this box kind of cropped off this preterm data, but about 73% of the non-smoking homes, those infants were born preterm, and about 84% of those from smoking households were born preterm. When we get into the fun data and look at what was in the human milk samples from these mothers who gave us a sample to analyze, as you might expect, mothers or postpartum people who were from non-smoking households tended to have lower levels, but we still picked up nicotine in their samples. And even when you look at this yellow box, when I removed the two individuals who smoked and gave us a human milk sample, you still see a pretty high level of cotinine in the breast milk for these mothers and people who are simply exposed to smoke in their household. And then at the bottom, I've highlighted NNAL is just a metabolite of a very tobacco-specific carcinogen called NNK. And it's interesting that both the carcinogen and its metabolite are carcinogenic. And of the two women who smoked and gave a human milk sample, we picked up the presence of this tobacco-specific carcinogenic metabolite, and we were the first to demonstrate that. Previously, it had only been shown in the animal literature, and so I think Dr. Greiner made a good point. You know, being exposed to this one time necessarily isn't going to lead to health consequences, but you know, if an infant is breastfed over 6 months or a year, and this person who is pumping or breastfeeding continues to be exposed, and NNK, that carcinogen, and its metabolite are constantly flowing downstream to this infant's gut, that could have a real impact on the developing gut microbiome and several other health outcomes. And so here are a few of the data on the gut microbiome. Alpha diversity, this particular graph on the left that says observed OTUs is talking about kind of the richness of the gut microbiome, and the graph on the left labeled Shannon is talking about richness as well, but kind of the evenness of the gut microbiome development. And the black dots are from infants who are going to be discharging to a home where at least one person smokes, and the gray dots are from infants who are going to be discharging to a completely tobacco-free home. And that red dashed line, as you can quickly pick up, shows that greater concentration of the infants being discharged to homes where individuals who smoke live have lower levels of diversity in their gut, kind of healthy, less healthy levels of diversity. And these boxes at the bottom in green and red are just demonstrating significant correlations between some of the measurements we took, whether it was surface nicotine, higher surface nicotine correlating with lower levels of diversity, and living with a smoker correlating with lower levels of these measures of diversity too. And this next graph looks really complicated, but the major takeaway is in the green box. Bifidobacterium is significantly lower when we correlate it with infants' exposure while they're in the NICU, not after they've been discharged. Just want to underscore that one more time, that there's no secondhand smoke exposure. There's no exposure to anything other than third-hand smoke residues here. We found that Bifidobacterium relative abundance was suppressed or significantly lower in these infants who are going to discharge to homes where smoking occurs relative to infants who are going to discharge to those completely tobacco-free homes. I'm going to skip this slide because it's saying much of the same thing. And some of the conclusions we make at this point are that these early studies of third-hand smoke in a protected smoke-free hospital with this vulnerable pediatric population can show that it's being deposited there, and that really any third-hand smoke in these settings could pose a risk. We'll know more as time goes on about how great that risk is and how it might impact a hospital discharge or length of stay and other health outcomes we want to explore. But limitations are important to acknowledge. You know, much of this work relies on a single measurement, and we need more longitudinal or repeated evaluations. And a few of the next steps here will better characterize risks, exposure, and routes more so. And finally, I just want to leave you with a hand washing and sanitization study that was conducted, which is also published. And we recruited visitors who reported smoking and had the carbon monoxide breath level to demonstrate smoking on that day. And we would wipe 3 fingers, most implicated in smoking. And what we do is we randomly select a finger to wipe and wipe it. Then we would randomize them to either 30 seconds of hand washing or 30 seconds of sanitization with alcohol-based sanitizer. We'd wait 5 minutes, we'd wipe a second finger, and then after another 40 to 60 minutes, we'd wipe that third finger. And the order of these wipes changed, but we adjusted for the area of the finger in our analyses. And you can quickly tell by looking at the left-hand side that hand washing participants tended to have a pretty big drop in nicotine on their fingers. It didn't drop to zero for anyone, but it dropped. And then you see kind of a slow rebound of nicotine as it sweats back to the surface. On the right-hand side, it was a little bit more complicated for sanitization participants. Our great friend and colleague, Jorg Matt, hypothesized with me that maybe alcohol-based sanitizer kind of acts as a solvent for nicotine on the fingers, and you're really just kind of spreading it around all over your hand, not really getting rid of it. So maybe the concentration on the fingers is a little bit lower, but Dr. Mojave Gittin's great work on hands, may demonstrate that we didn't get rid of any. We simply just located it from the index finger to a different part of the palm. So a caregiver holding their infant is still going to have as much nicotine on their skin if they use that method of trying to remove it. And I apologize, but I have a conflict beginning at 1, so I'm not sure if there were any questions in the chat, but if anyone would like to ask me a clarifying remark about anything I presented or anything that might be specific to my piece, I'm happy to take that question now, and just wanted to briefly acknowledge a lot of the wonderful colleagues who've helped with this research over the years. So.
I don't see anything in the chat, Tom, and I'm happy if questions come up later, we could forward them to you. Would that be okay?
Sure.
Okay.
Great. Well, thank you for allowing us a chance to present, and I'll leave it in the very capable hands of my friend and colleague, Dr. Mojave Gittins.
Thank you so much, Dr. Northrup and Greiner, and happy to present my part now. Thank you, Dr. Greiner, for those. Okay, so today I'm going to talk about secondhand and thirdhand smoke exposure in the home and a little bit in the hospital setting as well. So I don't have any conflicts of interest, and this work was funded by the National Institute of Environmental Health Scientists. All right, so background. So as we all know, cigarette smoking rates, or at least combustible cigarette smoking rates, have been decreasing. Nevertheless, about 40% of children aged 3 to 11 years old are still exposed to tobacco smoke. And I say 3 to 11 because that's the information we have on children who are part of like national surveys like NHANES. However, we do know that rates are way higher in children who are younger. Also, tobacco smoke exposure, TSE rates are also higher at about 66% among racially diverse children and children who live in low-income households. The work that I've done at Cincinnati Children has shown that TSE, as measured with cotinine, has been confirmed to be as high as active adult smokers in infants and toddlers, which is startling and kind of heartbreaking as well. In the emergency department where I work in Cincinnati, parental smoking rates range from 30 to 48%. So almost 1 in 2 parents at any given time can be smokers who bring their children to the emergency department. Next slide. So as Dr. Greiner mentioned, there are a lot of clinical effects of tobacco smoke exposure, and this is defined as both secondhand and thirdhand smoke exposure. As you can see on this slide, the range is very broad, can include cognitive problems, allergies, kidney disease, wheezing, endocrine dysfunction, sudden infant death syndrome, cardiovascular diseases, cancer, and metabolic disorders and inflammatory processes. Next slide. The clinical effects of thirdhand smoke. So we're starting to understand this a little bit better. Laboratory research has shown that thirdhand smoke exposure is associated with metabolic dysfunction, delayed wound healing, hyperactivity, in animal studies, molecular and oxidative cell damage, and DNA damage, which results in genotoxic stress and cardiogenic risk. The pediatric concerns are, based on the fact that there, as Dr. Greiner mentioned, multiple exposure routes. Unlike secondhand smoke, kids can be exposed to third-hand smoke by touching, so dermal absorption, by ingesting objects that have third-hand smoke on it, and then of course by inhalation, just like secondhand smoke. There are ubiquitous reservoirs that are often unbeknownst to homeowners, and kids can have acute and chronic exposure. And of course, kids are smaller, they breathe faster, they're developmentally immature, so those anatomic and physiologic differences can also raise lots of pediatric concerns in terms of how children who are exposed are affected by third-hand smoke. Next slide. So I'm going to discuss two studies today. In the first study, we tried to answer some research gaps. The first question was, what are the third-hand smoke exposure levels as measured by hand nicotine in children of smokers who have tobacco smoke exposure? The next question was, what child characteristics are associated with high cotinine and hand nicotine? Third question was, is third-hand smoke exposure associated with children's overall tobacco smoke exposure as measured with cotinine? And is third-hand smoke exposure associated with clinical illnesses? So the results of this study was published in Environmental Research. It was called Differential Associations of Hand Nicotine and Urinary Cotinine with Children's Exposure to Tobacco Smoke and Clinical Outcomes. And in terms of the study design, so this was a study in which we conducted a parental tobacco cessation randomized controlled trial. This study occurred in the emergency department in urgent care at Cincinnati Children's. So we recruited parental smokers who brought their child in for a presumably and potentially tobacco smoke exposure related complaint. So the complaint could have been they had a cough, they had a cold, they had wheezing, that sort of thing. So because these children were lived with smokers, all of them were potentially at risk to have tobacco smoke exposure of some sort. We got multiple measures on the parents and the children. We asked them about their demographics. We asked, of course, about parental tobacco use and child tobacco smoke exposure patterns. So were there smoking bans, that sort of thing. And we got urinary cotinine on the children. As you remember, cotinine is a nicotine metabolite, so it shows how much kids have been exposed to both secondhand and thirdhand smoke. And we got hand nicotine levels, and hand nicotine levels is a measure measures the amount of thirdhand smoke pollution in the children's environment that children have been exposed to. So the way we did this, so in the emergency department, we created a sterile field in the room, and we, wipe children's hands. And as Dr. Northrup mentioned, we wipe the palm and the volar aspect of all of the children's fingers with distilled water and ascorbic acid. And then we also collected field blanks just to make sure that we didn't have any extraneous nicotine in the room where we were collecting the samples. And then samples were analyzed at San Diego State University using liquid chromatography with tandem mass spectrometry. Next slide. So in terms of the child characteristics, the mean age was about 5.3 years old. About 54% of the children were male, about 33% were non-Hispanic white, about 57% non-Hispanic Black, about 8% were other race, and about 1% were Hispanic. Most of the children had public insurance like Medicaid, and about 93%. Most of them had an income of less than $15,000 a year, so that was the household income, of course. And of the parents, about 50% had a high school education or less. And the median number of cigarettes smoked by these parents was about 10, so about half a pack a day. So when we analyzed the hand nicotine and codeine, what we found that 100% of these children had detectable hand nicotine. The range was 4 to 2,191 nanograms per white. The geometric mean was about 90 and the median was 103. So just for perspective, in other studies done at San Diego State University, they have found that adult non-smokers who had their fingers wiped, their level of finger nicotine was only 5.2 nanograms per white. Active smokers, their levels of hand nicotine were 630 to 650. So that just shows you that a level as high as 2,191 is just astronomical. In terms of codeine, not surprising, 100% had detectable urinary codeine. The range was 0.1 to 169. The geometric mean was 10. The median was 12. And also for perspective, we use a urinary codeine level of greater than 3 in general to define active smoking. So these children had levels of urinary codeine that we see in active smokers. We also found that hand nicotine and urinary codeine levels showed a strong positive correlation. Next slide. So overall, we found that if you can hit next again, Lydia. Yeah, so we found that hand nicotine levels were the highest in kids who were 2 to 4 years of age. And presumably what we think, because we've seen that in a number of studies since then, what we think is that this is probably because 2 to 4 year olds, they're toddlers, they're exploring their environment with their hands and their mouths, they're walking, they're getting into all sorts of mischief, and that's why they have high levels. But also recognize that other children, so the 0 to 1 year olds also had high hand nicotine, as did the 5 to 9 year olds and the 10 to 17 year olds. Also, what is very important to note is that hand nicotine was not significantly associated with child sex, child race and ethnicity, and by their insurance type or household income. Now, on the next slide, I'll explain that a little bit further. So we did a similar analysis looking at the same child characteristics, but based on codeine. And unlike hand nicotine, we found that urinary codeine was higher in children who were non-Hispanic Black. It was higher in children who had whose parents had less than a high school education or equivalent. It was also higher in children who had a lower household income, and it was higher in children who lived in multi-unit housing or apartments. But urinary codeine was not associated with age, sex, insurance type, chief complaint, or diagnoses. And the reason why this is important is because, as we mentioned, codeine is a nicotine metabolite, and codeine, therefore, is metabolized through the liver and is associated with different, I don't want to get into all of the details, but there can be certain, kids can have certain genotypes that can either result in them being a fast metabolizer or a slower metabolizer, and that will affect what their codeine level is, even if they are exposed to fewer cigarettes, for example. And the reason why this is important is because since hand nicotine was not associated with different racial differences, it shows that hand nicotine may be a really good marker that has not been used enough in the past to show exactly what children are exposed to and exactly what they are touching, unlike codeine, which they can't control quite as well. Next slide. So in this study, we also were very interested in knowing if hand nicotine levels were associated with different illnesses. And we found that it really was. We found that in children with viral or other infectious disease diagnoses, they were 7.5 times more, higher hand nicotine levels placed children at risk to be 7.5 times more likely to have viral or other infectious diseases. Higher hand nicotine levels also was associated with a higher likelihood, up to 5.5 times more likely to have a bacterial diagnosis, and higher hand nicotine levels were associated with 6.6 times increased likelihood of having a pulmonary diagnosis. However, as you can see from the bottom row, log cotinine level, so the higher your cotinine level, was not associated with any of those diagnoses. Next slide. So in summary for this study, we found that smokers' children with higher hand nicotine levels were at higher risk of being diagnosed with infectious or respiratory illnesses. Hand nicotine is a predictor of clinical outcomes independent of urinary cotinine. Since there was no association with diagnoses and cotinines, it shows that hand nicotine and cotinine are not redundant markers, and that hand nicotine provides differential insights that are not captured by cotinine. And also, very important to note is that third-hand smoke exposure may contribute to similar illnesses in children that were previously thought to be associated with secondhand smoke exposure, but we didn't have the insight to be thinking, could it possibly be associated with third-hand smoke exposure? Next slide. So this, I'm going to briefly discuss another study, final study I'll discuss, and this study was set to answer, do children of non-smokers have measurable third-hand smoke exposure? And what child's characteristics are associated with third-hand smoke exposure in children of non-smokers? So the results of this study, at least the preliminary results, it was published in JAMA Network Open. It's called Prevalence and Income-Related Disparities in Third-Hand Smoke Exposure to Children. Next slide. So this study was called the Advocate Study, which stands for Assessment, Detection, and Validation of Clinical Associations of Third-Hand Smoke Exposure. Very briefly, we recruited about 800 parental non-smokers and 200 parental smokers. And based on the children's salivary cotinine and hand nicotine results and survey results, we classified children as being protected, so they lived with non-smokers and were not around smoke, or unprotected, so they lived with smokers and were around smoke. Next slide. So in this study, in that portion that was published, we took a convenient sample of 504 aggregate participants who were less than 12 years of age who had hand nicotine results available. Because we started this study in February of 2020, of course, COVID hit, so we had to shift and not enroll everybody from the pediatric emergency department. So about 269 children were enrolled from the ED, and about 235 children were children of Cincinnati Children's Hospital employees. Got hand wipes on everybody. This portion of the study was February of 2020 to May of 21. Next slide. So we called children protected from tobacco smoke exposure if the parents did not smoke or vape, if there were smoking and vaping bans in the home and car, and if the child had no known contact with tobacco product users in the past week. Next slide. And then we asked about parents' tobacco product use. So of course, parents who were non-smokers, they said none. Parents who were smokers, we asked if they were exclusive cigarette users, exclusive cigar users, exclusive e-cig users, or dual or poly tobacco users. Next slide. And then we asked about child TSE patterns and child characteristics. So we asked about home smoking rules. So you allowed smoking in the home or car, the number of tobacco product users that the child had contact with in the past week. We asked about sociodemographics and the home type. So like private home versus multi-unit housing. Next slide. So here's a brief summary of the child's characteristics. So about the mean age was about 5.7, about 50% of the kids almost were female, and we had about 66.3% of the children were white non-Hispanic and 29% were Black non-Hispanic. And then in terms of education, we had only about 20.3% had less than a high school education. And then in terms of income, much different than the previous study, about 21% had an income of less than $15,000. Next slide. So we got some results. So we looked at hand nicotine results overall and by tobacco smoke exposure status. So as you can see in the total sample, 96.2% had detectable hand nicotine. In the unprotected from TSE group, you want to click again, please? We had, so about 98% had detectable hand nicotine. The geometric mean was 22 and the median was 20. In the protected group, surprisingly, 95% had hand nicotine levels that were detectable. The geometric mean was 2.9 and the median was 2.4. Next slide. So we found again that the highest hand nicotine levels were in children who were 2 to 4 years of age, children who came from low income homes, and children, of course, whose parents used any tobacco products and who had had multiple contacts with tobacco users and who had no smoking bans. Next slide. However, looking at protected children only in the multiple regression model, we found that parent race and income accounted for 27% of the variance in hand nicotine. Next slide. Specifically, in protected children, we found that children who had a Black parent had higher hand nicotine levels than children who had a white parent and children who had multiracial parents. Next slide. And this slide shows something interesting. So this figure indicates, so if you can look at the left, okay, so you could see less than children who had an income of less than 15,000. So among those who were thought to be protected, so that's the lower blue line, those from the lowest income at less than or equal to 15,000, and those from the second lowest income, so that's the second point at greater than 15 to 30,000, had 5.7 times and 1.7 times higher levels of hand nicotine, respectively, than families who had incomes that were over 30,000. It's also important to note, actually, let's skip that part. Okay, next slide. So in conclusion on this study, we found that 95% of children have evidence of third-hand smoke exposure. So even though no one in their home used tobacco or vaped, and that even if smoking and vaping bans were in place, and there was no known contact with users of tobacco products over the past week, 95% of these children still had detectable hand nicotine. Next slide. Also, the strong association between hand nicotine and family income points to the role of tobacco in creating and maintaining health disparities long after smokers have quit and families adopt tobacco-free policies and families move into non-smoking housing. Next slide. Also shows that decades of permissive indoor smoking policies and practices have created a toxic legacy of persistent tobacco smoke pollutants in indoor environments. And I just have some reference there. And I think Dr. Greiner is going to take us to policy implications.
I am going to do that in our last few minutes. We're also actually going to ask you all for some input, so I hope you're ready to chat with us. One point we'd like to start out with is that our current policies fail to protect us from third-hand smoke. The policies that we have now that have to do with tobacco use are really designed to protect us from secondhand smoke. They just don't cut it for third-hand smoke. This slide is a review of all of the reasons why that is true. And I think that you could probably tell us what should be on the slide in terms of the differences in the way secondhand smoke and third-hand smoke behave and persist, exposure routes, where it's located, and also how difficult it is to remove, because once these reservoirs are established in indoor environments, deep cleaning can provide a temporary reduction. However, significant reservoirs need removal and renovation, which can be extremely costly. So one of the things that we can do about this is we can work toward policy change. The first one, redefine smoke-free as tobacco-free pollutant. Redefine smoke-free as free of tobacco smoke pollutants. So that means starting with smoke-free policies in multi-unit housing, for example. It means defining all indoor spaces as free of tobacco smoke pollutants in air, surfaces, and dust, everything embedded in material. It means addressing what has built up in times of previous active smoking and addressing that third-hand smoke pollutants can be transported from place to place. Another policy initiative that we could work toward is identifying indoor spaces that are polluted with third-hand smoke so that people don't purchase or move into spaces that are polluted unknowingly. Eliminating exceptions to comprehensive indoor smoking bans, closing loopholes, for example, allowing smoking to take place when children are not present in childcare settings. And kudos to the state of Iowa, because your childcare tobacco policies do not allow smoking anytime, whether children are present or not. But not every state in the United States is like that. And also, we need some policies to directly address the remediation of third-hand smoke. It costs a lot to get rid of this. And who should bear the cost? One might suggest the tobacco industry. So these are big, long-term goals that we can all work toward. However, in the meantime, we can also implement strategies to prevent exposure. First and foremost is encourage everyone who uses combustible tobacco products to stop. That means we need to regularly screen. We need to make sure that cessation support is freely available and that prevention education is freely available for all ages. Educating stakeholders, including healthcare providers, childcare providers, and parents about third-hand smoke. The hyperlink here, Guide to Secondhand Smoke and Third-Hand Smoke, is a educational module designed for primary care resident training programs. Dr. Mojave Gittins helped with the development of this and helped us create meaningful case studies that people who take this course can access at the end. You're all welcome to click on the link and take the course. We have a study that we have just had published that looks at parents and their need for third-hand smoke education. And we found that there are particular groups of parents who are really in need of third-hand smoke prevention messaging. One is first-time parents. Another is, regardless of whether you're a first-time or second, third, fourth-time parent, people who rent, people who use tobacco, and parents of adolescents, particularly if if they show up, they have a young child and they have an adolescent. Those folks need to hear the message about third-hand smoke again. We can work with folks to promote smoke-free indoor environments, make sure that people understand the importance of smoking bans on personal property, including homes and cars, and making sure that childcare providers and childcare settings are smoke-free. I would like to close with just a few real-time or real-life examples that we have experienced, and then we're available for questions. We operate from the premise that there is no safe level of exposure to tobacco smoke. We have people who call us and say, for example, my mom lives with us and she smokes. I have a new baby. What should I do? My uncle gave us a used car and he smoked in it. Can I use it to take my child back and forth to the childcare provider? I saw one of the workers at my child's daycare smoking in her car. How can I address that? We spend a lot of time at my family's home and several people there smoke. Can I continue to go visit folks in my family's home with my new baby. I'm going to stop sharing. Sorry. And I think we should open it up for questions if people want to chat with us. Sorry for that camera glitch. I see, is that handout available to us in the chat? Bethany, I'm not sure what handout you're asking about.
Lydia, I think it was a few slides back. It would be the secondhand smoke versus third-hand smoke.
Oh, yes,
And that popped up.
yes, absolutely.
And that is on your third-hand smoke website. Is that where they could find that as well?
Yes. We're in the middle of making a new website. It'll launch on September 3rd, but I can put that on our website, thirdhandsmoke.org, and make it available.
Lydia, if there's any handouts that you would like to share with those that came to the presentation, if we can post those on our website with the presentation, would that be an option?
Absolutely.
Okay.
And that would be very efficient, Marietta. Thank you.
Okay, we will do that.
Lydia, I had a question. I have been, learning about third-hand smoke since I met you last year, and that's why I felt it was really important to bring more information. But I'm looking at it kind of from my standpoint of having taught people about lead and lead remediation. Would you say it's somewhat similar in like the home? I guess I'm just thinking, how do we get rid of this third-hand smoke? And drywall and that kind of thing. Is it similar, or does like painting over it help, or what?
So that's a really, really great question. And the answer is, like many times, it depends. We don't have levels like lead levels where we say this is the level at which intervention needs to be taken. We are working on establishing voluntary standards that would be adopted by the state of California. But right now, we don't have that. It depends on the size of the reservoir. And right now, we can offer, on a limited basis, do-it-yourself testing to people who are concerned about this. And then we offer suggestions on how to best remediate, remove, based on the results of the testing. We have recommendations from This Old House, if you're familiar with that show on PBS, that recommends 2 washes with TSP, which is in and of itself toxic, so should only be applied by a professional. And then 2 coats of alcohol-based primer, also toxic, and needs to be applied in a well-ventilated space. And then 2 coats of paint. We do not have the data to tell us if that is effective over the long term. This is not the answer you're looking for, I'm sure. And Dr. Mobbigans, please feel free to jump in if you have other information.
Yeah, no, that's accurate. That's kind of where we are right now.
We
I was
do
also wondering if there's recommendations for, if you purchase a car and then you've realized, that smoke smell is still there. Is it best to, clean it? Obviously, like you said, you could get a deep clean, but then like would seat covers help, or are you still, if you're able to smell it, is it still pretty bad?
so cars are different than houses. Cars are basically like sponges because they have so much carpeting and fabric. So we basically say you can't clean a car. So if the car smells like smoke, you shouldn't buy it. If the car has air fresheners hanging in it, one might wonder why that would be. We are working for disclosure laws to make it be a part of the car's history, whether or not it has been smoked in. We have worked with families who have one car, it has been smoked in, they have no other transportation options. And we offer the following advice, and this is on our website. Keep the windows open while driving, even if it's cold. Do not recirculate the air. So suck air in from the outside for air conditioning and heating. Don't allow the air to recirculate inside your car. If your child is in a car seat, put a towel between the car seat and the seat of the car. Remove the car seat whenever the child is not in it. Wash the car seat in between uses. Basically wash and wipe as much as you can the surfaces that the child comes in contact with or that you come in contact with. Because the child or you, whatever it comes in contact with, the contaminated, for example, seat cover, will be transferred to your skin or your clothes, and then you will in turn transfer it to wherever it is you go next.
Thank you.
Sorry.
Lydia, there's another question in the chat. Any information on the additional chemicals present in vaping mist?
Great question. So we know that there are polyaromatic hydrocarbons. We know that there is a lot of particulate matter. We don't know as much about it as we do about the residue from third-hand smoke, but the evidence that we do have is it behaves similarly. It is found in surfaces. Nicotine is nicotine, no matter how it's combusted, it's going to behave the same. We did a study with kids in a local high school who were concerned about vaping in their school bathrooms, and they found extraordinarily high levels of nicotine on the inside of the stall doors, and also high levels of nicotine on wristbands that they hung for 7 days to measure for secondhand smoke. And I can give you some links. Also, Mariette, I can send along some links on thirdhandsmoke.org, which is our website, has frequently asked questions that has a lot of this kind of information, hopefully available in digestible language. And if there is something that you see that you need, like that you think would be, this is great, but for moms who are breastfeeding or pumping milk, it would resonate more if it were like this and you have a specific request. We're happy to work with groups to tweak our information. We're happy to do social media posts with you if you are interested in that method of dissemination of information. Kind of anything we can do to get the word out to vulnerable populations.
Well, Lydia, I had the wrong button again. Two devices. I'm not seeing any other questions. And we're a little bit over time, so I think we'll try to wrap up here. Marita did put the surveys in the chat. If you could complete the survey and evaluation by Friday, that would be great. And we will work on that continuing education for you all.
Thank you
Marita,
very much for presenting. We really appreciate you sharing the research and your experience. This has been a great presentation.
We are most grateful that we were invited. So thank you very much.
Thank you, guys.
Thanks everyone for joining us. Have a great day.